Hey, Miss Marion here. Go ahead and get out a piece of paper. We're going to go through some starters. This is going to help us with the end of level tests. Go through the starters, answer these questions, and then come back to me. All right, let's go ahead and go through these. So number one, we're going to multiply in our 9, do the distributive property. So 9 times x is 9x, minus 9 times 1 is 9, and then 3x plus 3. I like to always put my variables on the left-hand side. So I'm going to subtract off 3x. 9x minus 3x is 6x, minus 9, and then 3. And we're going to go ahead and add 9 to both sides. We're going to have 6x equals 12. We're going to divide by 6. X is going to equal 2. For number 2, again, we're going to multiply in our 9. And we'll have 9x minus 9 equals 9x minus 9. All right, a couple of things. I noticed I have a 9x and a 9x. So my variables are the same. And then are my numbers the same? Yes, they have negative 9, negative 9. So let's kind of think back to it. What answer is this one? This is infinite, many solutions. All right, let's go ahead and look at number 3. So again, I always want to put my variables on the left-hand side. This is a positive 8x, so I'm going to subtract off 8x from both sides. So I'm going to get 1x equals 8 minus 8. Normally you cross those out, but we also know it equals 0. So this answer is x equals 0. All right, number 4, let's look at it. Can we take the square root of 2 and get a whole number? No. So we're going to leave it as square root of 2. Can I take the square root of 9 and get a whole number? Yes. Then answer is 3. Then I'm going to ask about it one more time. Can I go ahead and reduce this any further? No. So this is my answer, even though it looks kind of funny. Number 5, I want to go ahead and figure out what number multiplied by itself makes 36. So the answer is 6, but it's also negative 6. Both of these numbers work because if I took a negative 6 times a negative 6, that is positive 6. And if I take 6 times 6, that's also 36. Let's go ahead and go over some stuff from yesterday's assignment. So do the following, form a right triangle. So the number that is across from the 90 degrees is always our C. And then the other two are A and B. The A and the B, they don't matter as far as where they are. They're just legs, and so they're pretty much can go in the A or the B and it still works. The C is the one that we're going to be very particular on. So I have 12 squared plus 5 squared. Does that equal 13 squared? So let's go ahead and go through that. 12 squared is 144. 5 squared is 25. And then 13 squared is 169. Let's add these two numbers together. 144 plus 25. We have 169 equals 169. Do both sides of the equations work? Yes. So does it form a right triangle? Yes, it does. All right, here is our missing side kind of information. Again, always across from the 90 degree is a C. And so again, we're going to use a squared plus b squared equals c squared. Again, this only works with right triangles. And it's Pythagorean theorem. We're going to put in 3 squared, 7 squared, and then c squared. 3 squared is 9. 7 squared is 49. C squared, let's add 49 plus 9. We get 58 equals c squared. And then how do we get, we just want c by itself. What is the opposite of a square? That is a square root. So that is going to equal, really long decimal, 615773106. We want to round it to the nearest tenths. So we want to go ahead and look at the guy next to him. Is he 5 or above? No. So we're going to keep it the same. Again, here is another one. This time we're going to be solving for our legs. So we have a squared, b squared, c squared. Again, a c is always across from the right triangle. And then we have 3.6, and then we are looking for 3.6 squared, and then we're looking for b squared. So let's look at it. Let's do 3.6 squared is 12.69, b squared. 7.1 squared is 50.41. And here we're going to solve it like normal. So we're going to go ahead and the 12.69 is positive, so we're going to subtract off from both sides. So we're going to b squared equals, we have 50.41 minus 12.69. That is 37.51. And again, opposite of a square is a square root. So we're going to square root 37.51. And again, we're going to round it to the nearest tenths. So that's going to be 6.1. And so what we're doing is we're looking at this triangle, and this side is 36, and we're actually looking for C. So we're going to have 18 squared plus 36 squared equals the C squared. We're looking for that diagonal. So we have 18 squared is 324, 36 squared is 1296, and the 324 plus the 1296 together, 1620. And again, opposite is square. Square is a square root, so we're going to square root both sides, leaving this c by itself. And our answer is going to get 40.2, and it will be yards is our answer. All right, let's go ahead and grab our workbooks, and let's turn back to page 135. Let's read the I can statement for lesson 7. I can explain why the Pythagorean theorem is true. So pretty much we are proving the Pythagorean theorem. Give yourself a sentence on how you feel about that, and a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. All right, let's turn to page 63, and will you write down one thing that you notice and one thing that you wonder, and then come back to me. All right, something that I noticed, one of the figures is blue, the other one is green. They both have a square in the middle, and they have 90 degrees. Both of them have triangles, but one set is a right triangle, the other one is not. I wonder what we're looking for. Why are they two different colors? Why do they have different right triangles, or just triangles themselves? Any of these things can be something that we can notice or wonder. Let's go ahead and turn to page 64. And so both of these figures are shown here are squares with a side length of a plus b. Notice that the first figure is divided in 2 squares and 2 rectangles. The second is divided into a square and 4 right triangles with lengths of a and b. Let's call the hypotenuse of these also c. So we're going to be working with this figure and figuring out some things. So first of all, let's go ahead and find just the area of F and then the area of G. And so go ahead, pause, answer that question, and then come back to me. So let's look at F. F first. One side, if we look at it, is going to be a plus b. The other side is also going to be a plus b. So if we're just looking at F, we have it as, and then how do we find the area of a square? We're going to take the side length, so a plus b. We're going to multiply it also by the other side length, a plus b. And then just to make it really nice and pretty, I'm going to write these as a plus b and then squared, because I have 2 of them and both of them are multiplying together. For letter G square, notice how this side is a plus b, notice how this side is also a plus b or b plus a. And again, how do we find the area of it? We're going to take one side, a plus b. We're going to multiply it by the other side, which is a plus b. And notice how this is a plus b and then squared. So what we've just shown right now is that both of the squares are exactly the same. They have the same area, and we're going to use that in a second. Number 2, also on page 64, find the area of each of the 9 smaller regions shown in the figures and label them. So what does that mean? I'm going to go ahead and find the areas, like this area, this area, this area, this area, this one, this one, this one, this one, and this one. Go ahead and find all of those areas and then label them and then come back to me. All right, these are the areas that you should have found for each of the different pieces. And so go ahead, pause, make sure that you have the same areas as me, and then we're going to go ahead and use this to kind of prove the Pythagorean theorem. So make sure you have it. So pause, check it, and then come back to me. All right, so what we said before is that both of these squares, they equal each other. And what I'm going to do is I'm going to write down everything in F. And we know that we can take all these different small areas, add them together, and that's going to be F. So I'm going to have a squared plus ab plus ab plus b squared. Then I'm going to go ahead and I'm going to take everything in G, same kind of thing. So I'm going to have 1/2 ab plus 1/2 ab plus 1/2 ab plus, and then 1/2 ab. Then we also have our c squared in there. I'm going to come back to letter F for a second. I'm going to go ahead and I'm going to combine these ABs together. How many do I have? I have 2 of them. So I have a squared plus 2 ABs plus b squared. With letter G, I'm going to add all my ABs together. So 1/2 plus 1/2 plus 1/2 plus 1/2. What do I get? I get 2 ABs and then c squared. So from here, what I'm going to do is I notice that there is a 2ab on both sides. I'm going to subtract that off. And then I'm going to go ahead and see what I have left over. If I subtract both of those off, so a 2ab minus 2ab makes 0. We know that. What is left over? I have a squared plus b squared equals c squared. We have now just proven that the Pythagorean theorem is true. All right, so let's go ahead on page 65. Let's again work with the Pythagorean theorem. The numbers are a little bit different, but same thing. We're still going to go ahead and use that. The letter that's always crossed from the 90 degrees is always my c. So the Pythagorean theorem is a squared plus b squared equals c squared. My c is, they have it labeled as x, so I'm just going to put in x squared. And we have our a, and then we have our b. Now, does it matter which one is a, which one is b? Honestly, not really. It will still come out the same. So we're going to have 2 squared plus 5 squared. 2 squared is 4. 5 squared is 25 equals x squared. Let's go ahead and add those together. We get 29. And then, as I said before, opposite of a square is a square root. So we're going to square root both sides. Square root of 29 is a really long decimal, and we're going to round it to the nearest tenths. So again, we're going to look at the guy next to him. Is that 5 or above? Yes. Give the original a shove. And we're going to make it 5.4. Now let's look at the next one. This is a little bit different because we have a square root kind of in there. But again, we're still going to go ahead and just put in what we know into the Pythagorean theorem. So again, a squared plus b squared equals c squared. Across from the 90 degrees is always my c. And then I have square root of 8, and then that being squared plus, and then b squared. We can even put that in our calculator. We can do square root of 8 being squared, and it's going to be 8. So remember, square roots and squares, they're opposites of each other, so they cancel each other out. We're just going to have 8 sitting there, and then 4 squared is 16. We want to get b squared by himself. How do we do that? We're going to go ahead and subtract off 8 from both sides. We have b squared equals, what is 16 minus 8? Well, that is 8. Then opposite of square is a square root. Square root both sides. So we're going to have b equals, well, square root of 8 is a decimal. We're going to round it to the nearest tenths. So we have 0.2828, keep on going. Is that guy 5 or above? No, we're going to keep it the same as b equals 2.8. So remember that with the Pythagorean theorem, we can kind of see what's going on. This is a great way of actually looking again to see that both sides are equal. Notice here I have 1, 2, 3, 4 triangles. I have 1, 2, 3, 4 triangles also. So that makes it so both sides are equal to each other. If we kind of take off those triangles on both sides, we just get the a squared, b squared equals the c squared. All right, go ahead and go back to page 135. Write a sentence about how you feel. I can explain why the Pythagorean theorem is true. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And 4, I can teach it to my friend. We do have the practice problems in Canvas to go ahead and do. Make sure you get those done for today, and I hope you have a good day.